For this problem, let's calculate the work done by every force acting on the ball. And then we'll find the net work that acts on the ball. So, person's pushing to the right with a force of Fp, force of push. The ball naturally has a weight, Fg, and there's going to be a normal force as well. And those are all the relevant forces. The ball's rolling, so there's going to be very little to no friction. Now let's calculate the work that each of these forces does on the ball. So first of all, the work of the push on the ball will be the force of the push times the displacement of the ball, and then the cosine of the angle between them. So they said the person's going to push with 10 newtons, and the ball goes 10 meters in the positive x direction. And the angle between these vectors will be 0 because the push here is in the same direction as the displacement. So that's going to be 100 joules. Let's calculate the work that the force of gravity does on the ball. It'll be the weight times the delta x of the ball times the cosine of the angle between them. So the weight of this ball is a 50 kilogram ball. That's a weight of 490 newtons. And the ball goes 10 meters. But what angle is between the force of gravity and the direction of the ball's motion? Well, the force of gravity is directed down. But the ball doesn't go down. It goes to the right. So the angle between them two is actually 90 degrees. So how much work really gets done? 0. The force of gravity can't do any work in this situation because it pulls downward, but the ball is not allowed to go downward. And what about the work of the normal force? Well, I hope it's clear for the same reasoning as the previous one. The normal force is at 90 degrees with the displacement as well. So even though the normal force has to match the weight, and it has to push, upward instead of downward, the angle between them two is still 90. That's because the normal force pushes upward, but the ball doesn't go upward. It goes to the right. And for that reason, the normal force can't do any work here either. So now we know what force is really responsible for doing the positive work here. It is the push of the person on the ball. And that is actually going to be the net work as well. When we calculate the net work, we can simply sum up all the works that had been done that we had calculated previously. And it's a positive 100 joules. And what we want to see is that when positive work gets done on an object, the object's speed will increase.